So this lesson is going to be about using linear models with data, which means we're going to talk a lot about putting data into the calculator. Now, if you don't have a calculator with you at home, I'm going to do the data input so you'll still be able to get the information. However, you should make some notes on the side of your paper about the keys that we push to do certain things, okay? So you may want to make notes off to the side specifically about things like entering data. You may also want to put a note about finding an equation for the data. And then you also may want to put a note about graphing the data. So off on the side, you just might want to have these three things and some important keys we press on the calculator. There will also be a YouTube link that does a good job explaining this as well. Now for the vocab at the beginning of the lesson, I'm going to briefly discuss how we're going to use these things. I might write a little bit down, and then you also have your textbook as a resource to look up the vocab, and then we'll follow up on Monday when we go through this. So when we plot our data, if you look at these graphs that you see right here underneath the word correlation, when we plot data, it's just a bunch of points on a graph, and we're trying to see if they have any correlation, meaning do they kind of follow a pattern? Can we see that as one thing goes up, so does the other, or maybe the opposite of that relationship? So the examples you see here, we use the words weak, strong, and positive and negative to describe the type of correlation. So in the middle here, you see a scattering of points that are very random. That's no correlation. To the left of that, you see things that are considered negative correlation. So negative correlation is anything that would be correlated in a way that a line with a negative slope kind of looks like it would fit that information. So you then see the word strong and weak. In this first diagram, the strong picture, you can see that the data is much closer to forming a line than in the weak picture. But both of them are negative because of the direction of the data. Then to the right of the no correlation data plot, we have two plots that show positive correlation because as x increases, so does y. Again, there's a picture of what a weak and a strong would look like. So these are pretty subjective words, but we're going to use them to describe our data. During this, we're going to see something called a correlation coefficient. We usually refer to it as R. And R falls somewhere between -1 and +1. Negative and positive don't mean anything bad or good. Basically, you want to look at the absolute value of R, so whether it's negative or positive, and compare it to 0 and 1. And basically, the correlation coefficient tells you how good of a job the line does describing the data on like a scale from 0 to 1. So if I got an R value that equaled 0.99, I would say that's really strong positive correlation because my line seems to do 0.99 on a scale of 0 to 1, which is very high on that scale. Okay, we'll talk more about this in class so that we can understand it better. A trend line is a line we draw that goes with the trend of the data. So the lines that I've drawn in the pictures above would be considered trend lines. But there is exactly one line that fits the data best. And there is a calculation we do in order to find out which line fits the data best. The calculator will do that for us. And we'll talk a little bit more in class about how it decides why that line is better than another line. So trend line is any line, but we're going to be using the line of best fit, the actual best line to fit our data. Okay. And again, we use a linear regression process to find this. All right, so this is all about taking data, looking at the data, saying what's going on with the data, and then using it to predict what we think would happen in the future. So here's a table that shows the median home price in New Jersey, and then we are asked what is the equation of a trend line that models the relationship between time and home prices, and use that equation to predict the median home price in 2020. We're actually going to go find the best fit line using our calculators. So first we have to get the data into the calculator. So right now we're going to change screens from looking at the data to looking at the calculator. And again, if you have your calculator, follow along with us. If you don't have your calculator at home, again, you're still going to want to make notes about the keystrokes because there could be questions like this on your assessment. And we're going to be using this in class on Monday, so you want to have an idea of what to push, okay? And again, I don't expect perfection, but I do expect a very strong effort. So your questions should be very specific and pointed. They shouldn't just be things like, I don't know anything. So to put this data into the calculator, I would go to my calculator, and here's how we enter data. So if you're taking notes on entering data, you'd want to write these button pushes down. We go to Stat, and we go to Edit. Then notice there's a bunch of lists. If you have information in your list, arrow to the top so you're on the name of the list, press Clear, not Delete, Clear, and press Enter, and that will clear all of the data out of the list. And then do that in any other list which you wish to clear the data. Now I'm going to enter my data. So I have 1940, 1950, 1960, 1970, 1980, 1990, and 2000. Okay, then I'm going to go over to list 2. This is going to be like my Y list that you saw in the data, and I'm going to enter the prices. So 47,100, 63,100, 76,900, 89,900, 119,200, 207,400, 170,800. Kind of keep track if you entered your data right, your list should end at the same place. Ours do, so that looks pretty good. So that's how we enter the data that we want. The next thing we want to do is we want to look at a graph of just the data before we talk about how to get the equations. So up at your graphing buttons, where the Y equals and where it says stat plot, that's where you're doing plots of statistics. So I'm going to go second, Y equals, which takes me to the stat plot menu. And see, I can turn on lots of different types of graphs with statistics. So I'm going to go into the first one. I'm going to turn it on so that it will show it on the graph. I am going to do a scatter plot, so I like all this little dots right here. I'm not going to change that. My X list, I entered in the list called L1, so I'm going to keep that. And my Y list, I entered in the list called L2, and I'm fine with it making these little boxes for the marks on the data. Now, before I look at the graph of the data, my window is clearly going to be kind of weird because my X values were like 1940, 1950, and the calculator sees that as like 1,950. My Y values were things like 47,100, so I either need to adjust my window myself to see it, or in the zoom menu, so we're going to go to zoom, they actually have a zoom. Oh, sorry, let me try this again. Go to zoom. No, it's not letting me. Sorry, 1 minute, guys. I'm going to quit. I'm going to go to zoom. And then in our Zoom menu, there's actually part of the Zoom menu that is specifically for statistics. So if you see choice 9, it says Zoom Stat. It will take your statistics and zoom your window for you. So we're going to use that a lot. So I'm going to choose choice 9. So here you can see the data. I would say it's definitely a positive correlation, and it seems pretty strong. Like there's one pretty good line that describes it. We'll see how strong in just a minute. So I enter my data with stat edit. I use the stat plots to graph my data. Now how to get my equation. So to get an equation of the line that fits this data best, I'm going to go to stat, and I'm going to go over this time to calculate. Okay. I would like my calculator to calculate an equation of a line that fits this data, so I'm going to choose linear regression because it seems to fit the shape of a line. So I'm going to press enter. Now on some calculators you're going to see it like this, and on some they'll give you a better menu where they actually label things. We want the equation to be stored in Y1, so we need to do a couple of things. We need to tell the calculator where the first list of data is and where the second list. So we had our data in L1 and L2. So I'm going to click L1 and then put a comma. Then I'm going to click L2. I'm getting the list by pushing second and the number key, because you can see in blue that's where they have like L2. Then after this, I want to tell the calculator where to store the equation, so I don't have to retype it once it comes up with the equation. So I'm going to have it store my equation in Y1, like my Y equals graphing stuff. To get that Y, you have to go here to the variables button, and you're going to go over to the Y variables. You're going to choose the first choice function, and then you can choose which one you want it to store in. Y1, Y2, Y3. I'm just going to choose the first one. Okay. Now I'm going to press enter, and so you can see what it's done. If Y equals AX plus B is the equation of the line, I know you're used to MX plus B, but they just put an A in there, then A is 2,507.14, and B is negative 4,828,442.86. Now here's that R value we were talking about, the correlation coefficient, 0.92. That seems like that line is doing a pretty good job of describing my data, so that just helps me understand that this line is a pretty good representation of my data. So I'm going to go ahead and write down my equation. I'm going to go to 2 decimal places. And now I want you guys to notice that if you go to Y equals, the Y equals is stored in here, and if you go to graph, you can see the equation of the line. Now one comment about the R value. If you did not have the R value show up in your calculation, you need to turn on the diagnostic in your calculator. And the way that you do that is you go to second, catalog, and you're going to go down to D for diagnostic. You can scroll down there, or you can push alpha D. So I'm scrolling through the D for diagnostic. Okay, right here. So you can see the calculator has 2 choices. Sorry, I scrolled past it. Diagnostic off or diagnostic on. You need to make sure you turn your diagnostic on. So press that and then press enter, and it'll say that's done. And now when you do the calculation for the linear equation, the linear regression, you should see the R value if you didn't see it before. Okay, so you can go back through and you can do that. So going back to our data, okay, we got a line of best fit. Our line was Y equals 2,507.14x minus 4,828,442.86. Okay. Now remember, for us, X was the year and Y was the median price. So when they say use the equation to predict the median home price in 2020, then we want to plug in 2020 as our year and see what we get as our Y value, or as our median price. Okay? So when we plug this into the calculator, let's see what we get. So 2,507.14 times 2020 minus 4,828,442.86. So we get that y is equal to $235,979.94. So we would say that is our median price. So we have our line of best fit and our prediction based on that data. Okay. All right, we're going to look at another piece of data or another group of information. So this time it's the cost of movie tickets. So we're going to go through and do this again. Okay, so we're going to enter the data. We're going to get the line of best fit. We're going to describe how accurate our line of best fit is, and then again model some information. So on my calculator, we're going to clear out all the previous stuff we had. I'm going to go on my y equals. I'm going to clear it. Notice that the plot one is still on. I can leave it on and just go change my lists, or I could turn it off, change my list, and every time go back into turning it on. Okay. So now we're going to enter the new data. So I'm going to go to Stat, Edit. Okay. You can either enter your data in new lists, so you don't have to clear out your old data in case you still want your old data for something, or you can clear out your data and start again. Okay, so this time we had 1995, 1997, 1999, 2001, 2003, 2005, and 2007. Now, you don't have to enter the data as years. We could enter this like 0, 2, 4, 6, 8, 10, like how many years it was past the beginning, but then we would just interpret it a little bit differently. So then we're going to enter in the prices. So it was $435, $459, $506, $565, $603, $641, $688. Okay. Again, I'm going to go zoom, and I'm going to choose choice 9 because that zooms to my statistics. Okay. So we can see the data on the calculator. Now I'm going to go calculate the line, store it, and have it show up on the graph. So I'm going to go to Stat, Calculate. Again, I'm doing a linear regression. And again, I'm going to tell it where the data is and where I want it to store it. So list 1, list 2, and I want to store it in Y1. So I go to vars, yvars, function, Y1. And I press enter. So you can see everything. Look at our R value here. Our correlation coefficient is 0.999. That's really good. That means this line is a very good fit of our data. So when we describe how well it fits our data, we have that information. And then we can see our A values. This time I'll go to 3 decimal places since there's not really anything before the decimal for A. Okay, so I'm going to go back. And so what is the equation for the line of best fit? Using the actual year as X and the cost as Y, our line of best fit equation would be Y equals 0.218X minus 430.365. How accurate is your line of best fit? I would say our line is very accurate for 2 reasons. Now, you can't just use the R value, but one reason is the R value is 0.999, and the other reason is the way it looked with the data. go back and look how well the line, because there are some hiccups to the R value that we'll talk about later as we're doing this, but look at the data and look at the line. You can see how well the line lies upon the data that matches with the R value, and those two things together allow me to say that this line is very accurate. So then, based on my linear model, how much would I expect to pay for a movie in 2025? 2025 is a year, so it's my X. So I'm going to plug in 2025. Okay. And then I'm going to go ahead and do the calculation. So 0.218 times 2025 minus 430.365 is $11.09. Okay, so we might have already passed that in our movie theater, and maybe that doesn't make sense, but for the data that we had here, that's very accurate. We would feel like that's an accurate prediction of what's going on. So write down these notes. In class, we're going to do our own experiment, talk a little more about the best fit line and how your calculator really decides what the best fit is. We'll do a little experiment in class on Monday to see that. And then we'll talk about how to interpret the slope and y-intercepts of these equations and what everything means that we're getting from the data. So hopefully here you just have some examples and a general idea and how to enter everything into the calculator. And again, I'll also post a link to a YouTube video that does a good job explaining the calculator use as well.